Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look again at using an object library to manipulate a Microsoft Excel workbook. In our last video, we prepared a PowerBasic application to connect via COM to an Excel spreadsheet. This software can run either using the PowerBasic console or Windows compilers. There are two main things we're going to do today. We're going to sort out the problem with the Windows API, which we commented out in the last video, and we're going to add a new library to make it simpler and easier to use the COM objects to connect to Excel. So first of all, we'll sort out the Windows API call. When we put the call to the Windows 32 API back in and attempt to compile, we'll see we get a conflict. This conflict is between the PBXL include file, which we prepared using the COM browser, and one of the Windows API calls itself. So we're going to sort out this name conflict by changing the name of the interface in the file that came out of the COM browser. As we can see, there's more than one change needed. And now our application compiles quite cleanly. This allows us full access to the Windows API now. Those of you who downloaded the files from the website will have noticed I did not include the pbxl.include file. This is because it's generated by the COM browser, which is entirely dependent on the version of Excel you have on your machine. Therefore, if you have an older version of Excel, the include file that I generated may not be of use to you. So if you watch the previous video, you'll see how we used the COM browser to generate this file. Once you have generated that file, you can, as I did here, make the minor changes needed to make sure there's no conflict between it and the Windows 32 API include file. Now that we've got that sorted out, what we're going to do now is we're going to add a new library. We're going to add some common functions that let you manipulate objects within Excel much easier. In the PB main function, we have a process Excel spreadsheet function. And this, at the moment, is the thing that does all the work on the Excel spreadsheet. However, there is a fair amount of code within this function. We're going to tidy this up now. We're still going to require three objects. An object that is the interface to the Excel application itself, an object for the Excel workbook, and an object for the Excel worksheet. We're going to need less variables within this function, because a lot of the variables will actually only be used in the library. So we're going to make use of one of the library's new functions, a function to open an Excel application. This will instantiate Excel in your machine's memory. So this new function will take two parameters. It will take the object, which is going to be populated with the handle for the Excel application, and it'll take another parameter, which is going to be an error, should one occur, that we can pass back to our application. Then we can put that out to the log to tell the user why we were unable to launch Excel. There is also a function to close down the access to Excel itself. It will take three parameters, the objects for the application, the workbook, and the worksheet. This will close down access to Excel and clear the memory for these three objects. So in order to make use of these new functions, we need to include the library. I've called this new library PBXL Functions. If we do a quick compile, just to ensure the application is still compiling, we can make use of another function within the library which will effectively open the Excel workbook. It takes in the parameters of the Excel application, the Excel workbook, the name of the file we wish to open, and a variable to contain any error that has occurred. This can be printed out to the log to let the user know why we couldn't open the workbook. And as you can expect, there is also a function to open an Excel worksheet, taking in the parameters you'd expect for the application, the workbook, the worksheet, the sheet number we want to actually access, and any error that occurs. And our final task in the previous video was to take the worksheet we had selected and save this out to a CSV file. And there is a new function to perform this as well in our library, Save Excel Worksheet, taking the parameters of the worksheet, the file name we wish to save to, the file format we wish to save it in, and an error should one occur. This allows this function to be quite generic. All you need to do is pass it a long variable containing the type of the format that you wish to save in. So this is going to produce an output file, output.csv. If we try running the application now, Excel will be instantiated, the workbook is opened, and it's telling us the worksheet has been saved. If we look in the folder, we'll see there is now an output.csv file, which contains the data we would expect. So this is a basic functionality we had in the last video. However, I've gone a little further with the spreadsheet. If we open the spreadsheet itself, we'll see that the spreadsheet now has 3 worksheets. The My File worksheet, which is the one we've been working on, a second sheet, which is bigger, and a third sheet, which is smaller. We can perform the task of saving any one of these by changing a single line of code now. At the moment, we are set to use the first sheet. If we change that to 2, and then run our application again, it will open the workbook, and the pop-up message we see appearing on the screen here is actually coming from inside Excel. This is because the output.csv file already exists in the location, and Excel is prompting if you want to replace it. If you're creating an application which is to run unattended, this is obviously something you don't want to happen. So when it comes to generating output files, it's advisable that you put some code in your application to ensure that the output file does not exist before you run your application. You can do this quite easily in a try-catch block to kill the output file. In this case, we'll say yes, we want to overwrite it. And if we have a look in our folder, we'll see the output.csv now has a great deal more data in it, because it has in fact saved the second sheet. If we have a look at this new library just to see what's in it, we'll see that there are a number of functions. The Open Excel app we've used to open Excel, the Open Excel worksheet we've also used, and the Open Excel workbook. However, there are a couple more functions in here that you will find fairly useful. If we set it back for the moment to use the first sheet. Once we've opened the workbook, it would be useful to find out just how many worksheets exist in that workbook. So there's a function we can use to print that out to our log. And that function is called getWorksheetCount. This takes a single parameter, which is the Excel workbook. This will return a number, and we're turning that into a string so we can print it out to our log. Now we know there are 3 sheets in that workbook, so it should return a value of 3. So if we try running the application now, it will tell us that the sheet count is indeed 3. So after we open the Excel worksheet, we can also pull back from Excel the name of the sheet itself. We can do that using another of the new functions in our library, getCurrentWorksheetName. Since we've told the application which sheet we want to read, in this case sheet number 1, we want to pull back that name, passing simply the Excel worksheet object. If we run that now, it will tell us that the number of sheets is 3 and the worksheet name we're about to load is My File. So we can put a quite simple piece of code in to kill off the output file to ensure it does not exist before we call Excel to save its file. So if we run this once more, it will instantiate Excel, open the workbook, and save the data without prompting you to overwrite the file. So what we've achieved today is we've taken the common Excel functions and we've put them into a library. We can then use this library within any application that needs to access Excel, and it's something we can build on for future applications. It makes the code writing much easier. Plus, we've added a couple of new functions to tell us how many worksheets exist in a workbook and to pull back the name of a worksheet. So where your application needs to read an Excel spreadsheet and the sheet it needs to read is not necessarily in the correct position. It may be in sheet 1 or it may be in sheet 3. This way we can test for the name of that sheet and act accordingly. Hopefully you'll find this code useful in your applications, but that's it for today. Thank you for watching.